This is question 40 of civil engineering paper of GATE 2016 afternoon session. The seepage occurring through an earthen dam is represented by a flow net comprising of 10 equipotential drops and 20 flow channels. The coefficient of permeability of the soil is 3 millimeter per minute and the head loss is 5 meter. The rate of seepage through the earthen dam is. So, in this question, there is a seepage through an earthen dam which is represented by a flow net which comprises of 10 equipotential drops and 20 flow channels. The coefficient of permeability of the soil is given as 3 millimeter per minute and the head loss is given as 5 meter. Now, we need to estimate the rate of seepage through this earthen dam. So, this question is from the topic of flow through soil. You may study about this flow net and estimation of seepage by this flow net. In detail, you may study about this topic in detail in lecture 11, permeability and seepage, soil mechanics, geotechnical engineering 1 by Professor Dilip Kumar Baid, IIT Kharagpur. So, this equation is a partial differential equation known as Laplace equation for the two-dimensional flow in the isotropic soil. The general solution of this Laplace equation yields two sets of curves which are orthogonal to each other. One sets of curves are known as flow lines and another sets of curves are known as equipotential line. Equipotential lines. These two sets of curves forms a grid which are known as flow net. There are various uses of drawing flow net and one of the uses is to estimate the seepage loss. And the equation to find this seepage loss or rate of discharge is Q is equal to K into H into NF by ND, where K is the permeability of soil, H is the total head loss, NF is the number of flow channels and ND is the number of equipotential drops. Now, in this question, the value of K is given as 3 millimeter per minute, 3 millimeter per minute. So, we can write it as 3 into 10 to the power minus 3 by 60 meter per second. The value of head loss is given here is 5 meter, 5 meter. The number of flow channels is given here is 20. The number of flow channels is given as 20 and the number of equipotential drop is given in this question as 10. Now, substituting all this data in this equation, we get Q as Q is equal to K and the value of K is 3 into 10 to the power minus 3 by 60 meter per second into H. H is what? H is 5 meter into NF. NF is what? 20 by ND and the value of ND is 10. Now, when we solve this, we get Q as 5 into 10 to the power minus 4 meter cube per second per meter length of the dam, per meter length of the dam. Now, we can write this since in this question we need to answer in the unit of centimeter cube per second per meter length. So, for that we can write this 5 into 10 to the power minus 4 and since this was in meter cube per second. So, for writing it into centimeter cube per second, we can multiply it as 10 to the power 6 centimeter cube per second per meter length of the dam. per meter length of the dam. So now this will be 5 into 10 to the power minus 4 into 10 to the power 6. So we will get it as 500 centimeter cube per second per meter length of the dam. So here in this question, the rate of seepage through the earthen dams comes as 500 centimeter cube per second per meter length of the dam. So 500 is the correct answer for this question. Thank you.